Okay, I'm going to do an introduction for this Sec 2 mensuration. The topic on mensuration, you have done it in Sec 1. So in Sec 1, right, what did you cover? So mensuration is under the category of area, volume, surface area, parameter, all this. So this is under the whole family of area, parameter, volume, and surface area. So in Sec 1, you will have learned cube, you will have learned cuboid, and you will have learned cylinder, and you will have learned prism. So prism is the one that's most difficult in Sec 1. So when it comes to this topic, okay, now you're Sec 2, all the shapes that you have learned in Sec 1 will still be incorporated inside. So in Sec 2, you're going to add on 3 shapes: pyramid, cone, and sphere. So these 3 shapes we're going to add on to whatever that you have learned in Sec 1. Okay, of course, in Sec 1, you also learn things like trapezium. How do you calculate the area of trapezium, parallelogram, rhombus? So all these, right, will come into place. So all these are under the huge family of area and parameter, volume, and surface area. So you cannot cut them out. So we will be doing isolated shapes first before we're going to consolidate the shapes with the Sec 1 shapes. Okay, so we're going to focus on the new shapes before we add on the Sec 1 items that you have learned. So the shapes, there are 3 separate shapes, but I will be telling you that the pyramid and cone fall under the same family. So all of us have an idea of pyramids. So it's just that maybe you're not aware that a pyramid can have different base. There can be a triangle base, there can be a square base, a rectangle base, it can be a square base. So most probably the pyramid that you have in your head is like a square base one, a very nice pyramid, right? But in actual fact, we can have a lot of shapes. So including a circle. So that's why this is part of the pyramid family. Because it is still like a pyramid, except that the base is circle, a nice circle as a base. Okay, so what are the features of a pyramid? There is a sharp corner here. The sharp corner will hit the center of the base. It will hit the center of a base perpendicularly in a 90-degree. And because of this, there will be a lot of time you're using your Pythagoras theorem. Okay, so we'll introduce it a little bit further. So because this is a sharp vertex, it's like a sharp corner. So the formula will have a 1/3. So if you take a look, right, at the generic pyramid, is 1/3 base area. You need to go for the shape, depending on the shape. So if the base area is a rectangle, that means it's length and breadth. If the base area is a trapezium, then you're going to use the formula of a trapezium. That's why your Sec 1 work is related. So for the cone, right, the base is a circle. That's why we use the area of a circle as the base. And then there is a height. So this height, right, got to take note. It is a perpendicular height. This is the height that is perpendicular to the ground. Later on, you will see another height. Okay, another height can be called a slant height. So like, for example, this one is called a slant height. So later on, we talk about this. Okay, so for the volume of a pyramid is 1/3 base area times height. The base area depending on the shape. So if the base area is a circle, it actually becomes a cone. So the base area will be replaced by the circle, area of a circle. The height in both situations will be the perpendicular height. Drop to the ground at 90 degrees. Okay, so for the surface area, there is no formula if you realize. You have to add up all the pieces. So to add up all the pieces, you actually got to visualize how many pieces are there. So for example, in the situation of the rectangle pyramid, you should see the two opposite triangle. So the two opposite triangle are the same. And then you should see a front triangle, and there should be a back triangle as well. So how are you going to visualize it? You got to visualize it with a net. You know, you can do a primary school net to visualize. So you need to imagine that it actually fold up. So to do the surface area, you actually got to visualize the net. And then you got to add up the rectangle and the two triangle and the other two triangle. So that's why you got to add up the pieces. But when it comes to the cone, it's not so complicated. If you look, for the cone, right, it's very easy. You just need a base, which is the circle. And you just need the curved surface area. So this part is the curved surface area. So the curvy part, right, is the pi RL. So if you eat a cone, right, you know the crispy cone, you know the cone that they put one scoop of ice cream. There's no base because it's hollow. Okay, so the part that you are eating, that's cone, okay, it is the slanted, it's the curved surface area. You know the crispy part, okay, the crunchy part, right? That one is the curved surface area. So the formula will be a pi RL. And because of that, there's usually a lot of time you're going to do a bidigress here. So there will be a bidigress that happens here. So bidigress is going to be quite common in cone. Bidigress also be quite common with the pyramid. Okay, so there's a lot of bidigress, especially in pyramid, and it's a bit unseen. So that will be the introduction for pyramid and cone. Sphere, we'll talk it out in another teaching worksheet. So currently you should be able to see cone as part of the pyramid family. Yes, you should find some similarity in the formula. And subsequently, later on, right, a cone is usually mixed with a cylinder. So in the consolidation part, it will be a very common question where you've got a cylinder and you add a cone on top. So it's a very normal thing. Or they can have even two cones. You know, sometimes they can make a toy. Okay, so for pyramid, sometimes they will put it on top of a cuboid or a cube. So we can have a cube. And then they will stack the pyramid on top. Okay, I'm quite bad with my drawing. Can see? Okay, so there's a lot of mixture. So you begin to see a compilation of different shapes being combined, and you see different shapes, different figure. So later on, when we add on the hemisphere, you will get an ice cream cone, a very typical ice cream cone. So later on, we'll talk about it. So that is the basic introduction here first.